And there we are. Hello, everyone. Thank you for joining me today. Welcome to PaPawsProjects. Today, what we are going to do is we're going to get into Blender and dabble a little bit and see if we can make a part for the 3D printer that I'm building. So stick around. So let me start off by saying, if you're new to the channel and you like what you see, it's primarily going to be 3D related or Blender design topics on my channel. So if you like what you see and you want to see more of it, I would appreciate it if you would click on the subscribe button and click the notification bell if you'd like to receive notifications anytime I upload new content. With that being said, let's get into it. Alrighty. So, what we're going to do today is I am going to design a piece for the 3D printer that I'm building. If you've watched my other videos, you're familiar. We're redesigning the printer and going to go a different route. So, mechanically, we're kind of starting from scratch again. What I want to do is I'm going to build the new printer with this extrusion that is round with a couple grooves in it, and we're going to use these bearings. This bearing came out of a fidget spinner. I believe it's a 608 bearing. And I've got several of those. I found some fidget spinners that were on clearance sale, and I popped the bearings out. I also have a pack that I got from Amazon. I don't remember what I paid for them, but I know I paid $1 for each fidget spinner, and each fidget spinner had 4 of these bearings. So I know going that route, I had about a quarter a piece in each one. I'll have to go back and look and see what I paid for a 10-pack at Amazon, but I don't think it was much. But anyway, it fits perfect in the groove of this extrusion. This extrusion I have scrapped out of a couple old roller blinds that I had. And I think I've got plenty of it for my new design on the printer. The problem is, if you noticed, you hear that metal to metal contact. That's just going to shave aluminum off in the track, and I don't want that. So what I want to do is I want to create basically a tire for this to go on the outside that I can press this into, and it has a matching profile to fit down in the groove of that extrusion. And that'll give me a softer, more forgiving contact surface between the bearing and the extrusion. And it's replaceable. As it wears out, all I got to do is print a new one and pop it on the bearing, and good to go for a while again. I hope it's going to work. I think it's going to work. It might not work, but we're going to give it a try anyway. So, with that, let me tell you right up front, I am less than a novice at Blender. I am learning from the very basics and got a long way to go, but I think I know enough that I can get this designed. I know enough about it to know what I need to do. It's just being familiar with the Blender interface and know what tools to get where I need to go. So hopefully we can work that out. So before we get started, we need to get some measurements so we know what we're dealing with. So we're going to start with this bearing. Got my digital dial calipers here. And we're going to get a few measurements. So we're going to get the outer diameter, and that is 22 millimeters. We're going to get the inner diameter, and that is 8 millimeters. And we need the thickness of the bearing, and that is 7 millimeters. Okay, so we have 22, 8, and 7. Now I also need a couple other measurements, those being the width of the groove. I know the bearing fits in there, but I need to know how much tolerance I have to work with. Okay, so looks like I have 7.2. And how much depth I have in the groove, I just got to kind of eyeball because I don't have a top surface to measure against, but it looks like it is 5 millimeters deep. So 7.2 and 5 millimeters deep. All right, I think that gives us enough information that we can design this thing up. So let me see if I can pop over here to the Blender screen. Is it there? Yes. Okay. So now that we're in Blender, we're going to do this as simply as I can. When you're a beginner at Blender and you start editing things, it doesn't take long for everything to get out of whack. So I try to be as simple and quick as I can, not to try to overwork the problem. So what we're going to do first is I'm going to start with Create, and I'm going to start with the largest diameter piece of the tire. May not be the right way to go, or somebody might do it differently, but that just makes sense to me. So we're going to try it this way. So I'm going to start with a cylinder, and that cylinder needs to be, the bearing is 22 millimeters. I need a couple millimeters of meat there for everything to be held together, because it's going to have a 22 millimeter hole through the center of it. So if I add a couple millimeters to that diameter, that puts me at 26, because I got to add it to both sides of the diameter. And then I want it to go down into the groove. It's 5 millimeters deep, so we're going to go down about 4. So 26, 34 millimeters in diameter. That's what we want to make the outer diameter of this. So 34. And it's asking for a radius instead of a diameter, so we cut that in half. So we're going to give it a 17 millimeter outer diameter. Now, we're going to give it a thickness of 3.5, which is, no, we don't want to do that. I'm not doing a diameter there, I'm doing a thickness. So let's make that the 7 millimeters thick. There we go. Okay, so there's the largest outer diameter of the tire. And now I want to extend that out sideways on each side. Once we get this portion, will ride down in the groove, and then 4 millimeters up we need a ledge, which will actually be the rolling surface on the extrusion. So let's do a, without moving this, keeping everything on its center origin, we're going to add another cylinder. This one here, if you'll notice, is named cylinder. So we're going to add another cylinder, and you'll see cylinder 001 has been created, and that's the one we're working with. And let's see, I want to take away, this is 34 millimeters. So we'll take 4 millimeters off of here, that takes me to 30, and 4 millimeters off of here, so that's going to give us 26 millimeters of diameter, and they want a radius, so we have to cut it in half. So there's 13 millimeters. You can see the line there of what we've got, and I want it to be wider. I want it to extend out, let's see, say 3 millimeters on each side. So 7 and 6 is 13. All right, now I don't want to move the origin, but I want to look and make sure I got it on both sides, and I do. Okay, so we're looking good so far. So now we have the section that's going to go down in the groove. We have the section that's going to ride on the ridge of the groove. And now we need to create a hole here to press the bearing in. Well, before I do, I like this, so let's lock this in. Let me take, in object mode, click on the cylinder, and we're going to click on the wrench. We're going to add a modifier, a Boolean modifier, and we're going to tell it to use a union to join the cylinder with cylinder 1, this one, and say apply. Okay, now we should be one piece. So I should be able to delete this one, and now we have just cylinder, and it encompasses this whole object. So far so good. Okay, now let's move on to the hole. So we have cylinder. We're going to create a new cylinder, and it needs to be the right size for that bearing. And the bearing was 22 millimeters. So that's a radius of 11. And I want to give it a little bit of clearance, because I believe if I do this at 11, it's going to be so tight I can't get the bearing in. So I'm going to say 11.025. Let's try that. I'm just guessing here. So we may have to adjust it later and reprint it. And I want the depth. This is 13. I want a ledge on the bottom of the hole so that I can push the bearing all the way in until it seats against that ledge, because I want that bearing to be centered in this. So let's say 3 millimeter ledge. So let's take 3 millimeters off of that, and let's make this 10 millimeters thick. And you can't see it any longer because it's inside the model, but I can take that cylinder now and set its location to Z positive 1.5 millimeters. Should bring it back to the top, and it did. Okay, now what that's going to do is the cylinder that I created, which is still inside this object, I have offset it out of center by 3 millimeters. 1.5 millimeters on each side of this origin point. So with that made, we should be able to get a good hole. Matter of fact, let me make that 1.51 just to make sure it positively comes out the top. And let's try that. Okay, now again we have cylinder and cylinder 1, which is the new cylinder inside here. So we're going to go to cylinder, we're going to add a modifier, a Boolean modifier, and this time we're going to check difference, which is a subtraction. So we're going to take this object named cylinder, and we're going to subtract the new cylinder that we put inside here, we're going to say apply. Now, if we did this right, and I remove this cylinder, we have our hole. Still looking good. Okay, and we only have one object, so we're still doing good there. All right, now, what else do I need to do? I actually need to come in from that ledge and punch another hole all the way through it. So let's do it again. Let's say cylinder, and it pulls up the last settings that I typed in. So we were punching a 22 millimeter hole, or slightly over, to begin with. So let's change this. Let's let it come in 2 millimeters, 11, 10, 9, 8, 7. So let's change that to 7 in diameter. Ooh. Or radius, I'm sorry. So that makes it 14. I don't want it 14. That's too much. I don't want this wall to be rubbing the inner race of that bearing. Let's change this to 9. That's better. Okay. 9 on the radius. That leaves 10, 11. And then on this side, it's another 9 and 10, 11. So that's 22. There we go. That's what I was looking for. And just to make sure this plug gets a good clean hole all the way through, I'm just going to set that at 40. Just make it crazy. And it should be through both sides, and it is. So we're going to do the same thing we just did. We are going to take cylinder, which is our main object, add a Boolean modifier, difference, so that we can subtract, and we want to subtract cylinder 1 from cylinder, and we're going to say apply. Now, again, if we've done it right, we should be able to click on cylinder 1 and delete it, and there we are. We have our hole, and we have our landing down here. We should be able to press the bearing in and butt it up against that ledge and be centered. Okay, so that's the bulk of it right there. I think now I want to just do a little bit more finish work to it. So let's get risky here and switch to edit mode. Cylinder, edit mode, and we want to select some faces. That face. That face, and I'm just holding the shift key down as I click on faces. Now let's carefully rotate it so we can get some more. And there's probably an easier way to do this, but I want to be very careful. Take my time and not screw up what I've already got. So we're going to select all the faces around the outer tire, and there we go. Now, if I've got this correct, we should be able to hit in edit mode Control B. Yeah. And well, I don't know what I'm doing here, but there we go. Put a chamfer on there. That looks kind of pretty. So let's try that. Click it. So we set it. All right. And I did that because I didn't want those sharp corners digging into the aluminum. I don't think it would hurt anything. It would wear the plastic pretty quick, I would think, but it would offer some extra friction. So if I can eliminate that, this tire should roll a little better. Now I am going to print this out of PLA because I don't have this. Actually, I only have one roll of filament, so it has to be made out of PLA. But maybe later down the road I can do it out of a more softer, flexible filament someday when I get more filament. But for now, we're going to make it out of this Sunlu yellow PLA because that's all I got. Okay, so now what I want to do to soften up the edges of this chamfer, I can tell it, let's break that up into 8 segments and round it over. That should do what I want. And now if I go back to object mode, there is my tire. All right, and let's save as. Let's save as. Tire. Final. No. Let's do finished tire and save it. Okay, now. Oh, save as Blender file. Evidently clicking enter does not do that. Alright, and so now I won't lose what I've got. I'm pretty happy with this. I don't have this stuff down, but we'll take a look at it. If I go to the 3D add-on and I click check all, it's going to come down here and tell me of any issues, and it looks like we're good. We have overhanging faces is all, and that's obvious, so we're good there. All right, so now let's go back, and I'm going to export this as an STL file, and I'm going to put it on the desktop. And export it. Okay. So, I think we're doing pretty good. Let's go back here. And there we go. All right, so we have created the tire in Blender. I think let's give it a try. Let's see if we can print it. I won't let this video run for the whole print, but we will get it up and get it on the printer and running. Okay, maybe. Let's see if I can get Cura to come up here and share the screen. That's going to take me just a second. Bear with me. Cura screen. And if I go to the Cura screen, and I need to fire up Cura. Sorry I didn't have this up and running ahead of time. Okay. hopefully it's recording well. It looks like I've got some skipped frames. Alright, so we got Cura running in the background. And now we're going to do a window capture, add source, add new source, Cura, done. Okay, hopefully this will work. It's a little bit of a pain to do on the fly, but let's see. Should be able to bring up Cura for you. All right, now looks like I actually have it. Open twice. I'm going to have to kill one and see which one I have. And that was the wrong one. So let's try it again. Window capture. There's Cura. And come on now. Be nice to me. There we go. Come on. Okay. Explorer, OBS. Well, I'm not showing. Done. Window capture. Now, do we have it? Hopefully. So, yeah, we're not doing that upgrade again. I am going to upgrade it to 3.4 later. But for now, we're going to stick with the one that came with it because it makes beautiful prints. Okay, sorry about that. Now, let's see if I can find the file. I'll open the file. And it should be on the desktop. 3D, finish tire, and there we are. Okay, and let's see here. Quality, gel, infill, 90%. Honestly, I don't have a lot of experience with the settings on this yet, so a lot of it is just guessing, but surely that'll be okay. Those settings have been working great for me. Speed, cooling, support, generate support. Everywhere, touching plate. I'm going to leave it on touching plate. And we should be good. Let me pop the card in there and transfer it over to the SD card. Okay, and there's the SD card. I was doing some tinkering yesterday. Did not work out so well, but I think we're going to have a winner. So, I might have messed up. Well, oh no, there it is. I thought the box was over here, but there it is. So save to removable drive. There's the box I was thinking of. And eject. All right, and now we should be able to take and shut down Cura. Let me go back here to OBS, full screen. Okay, we're getting close, people. Let's see if I have a camera, HP camera. Okay, let me see if I can get see if I can get a camera set up here so you can see. Well, maybe you can see. All right, I think this is going to work. So let me pop over to the other camera, and we will put the SD card in there. We will fire it up. On. Print from SD card, finish tire. All right. So we have the bed heating up right now. Let's see if I can get another screen up here while we wait for that. Let's deactivate the camera on there and activate. Nothing ever wants to work on my time frame. Let's see if there's another one. Let's add video capture. Let's add this one. Let's add another video capture, which is this one, and okay, let's try that. And transition over. There we go. Okay, now, there we go. Let's transition again. All right, so hopefully we've got this thing. We have the bed up to temperature, and we have the nozzle almost to temperature. Should be starting here in just a minute. I'm definitely going to upgrade to the Cura 3.4. I went on and upgraded to the 3.5, and it just gave me crappy prints. So I tried to fix some settings in there and it got better, but it never did actually print well. So I just went back to the 3.0 that came on the flash drive. But everybody's saying that 3.4 is good to go, so I'm going to try to upgrade to that. One of the things I noticed when I had 3.5 Cura on there was the hotbed and the nozzle both were heating up simultaneously, where when I go back to this one, it does the heat bed first and then it does the nozzle. So hopefully 3.4 will let them come up together. It's not a big deal. I'm not in that big of a hurry, but it was nice. And she's off and running. So I think I will shut her down here and let this thing print, and then after it prints on my next video, I'll show you how she turned out, and we'll see if she fits in the extrusion and see if the bearing actually fits in there. And if not, we'll just continue working on it. If so, then awesome, we can move on to the next piece. Hopefully you will get something from the video, if nothing else, entertainment, or maybe just passing the day with background noise. I don't know. But before I go, let me say again, please hit the subscribe button. It helps me out a bunch. If you want notifications, don't forget to click the bell. And hopefully the content will continue to get better. I'm always striving to make my channel better and make the production quality better, and the content better. So feel free to leave comments. Let me know if you got anything you like, don't like, want to see, don't want to see. Tell me about it. This thing is fluid, you know. I can change it up on a dime. So thank you for joining me, and I will see you again in the next video. See you soon. Bye-bye.